So in this course, we are mainly going to learn about how to build large language model applications, the applications which are based on LLMs. Large language models, for example, we have GPT-4o, we have Claude models and all those. So how we can use them to build application based on that, because these LLMs are very powerful. So they are already trained, and with a simple prompt, if you say classify the following sentiment, and then if you give the sentiment or a review of a movie or a product, it will be able to tell you whether that sentiment is a positive, negative, or neutral. Okay, so these LLMs are very capable. So that's why what we want to do, instead of training an entire model from scratch, preparing the data and then training the model for a given task, our aim is to utilize the large language model which is already being trained by some other company like OpenAI or like Meta, okay, or Google. So we will talk about LLMs, we will study about LLMs, how to build those applications, and we will use the LangChain framework, and we are going to have lots of hands-on and interactive exercises. Okay, so that's at a high level on the course introduction on this first module. Okay, uh, this is introduction. Basically, as I already said, we will understand how the LLMs work. In this first session, uh, what we are going to study is how LLMs work, how they are trained, how under the hood they generate the tokens, okay, and what are the different configuration parameters which, if we configure, can result into some different completion. We have also seen what is interference. Okay, so those things we are going to study in this particular class. So we started in the last class also, we started with AI and ML. I said AI is nothing but the artificial intelligence is nothing but when we have machines which try to do the task which generally human beings do, right? So the human being like capability is called as the artificial intelligence, and it's a big area. Okay, so it's a very wide area, and we have machine learning is a type of AI, and neural networks are a type of machine learning or a type of AI, like, so these are subcategories within the artificial intelligence. We have machine learning, we have the neural networks, we have the deep learning, we have generative AI, and within this generative AI area, we will be focusing more on how to utilize large language models. Okay, apart from that, this categorization can also be done from the type of task we are going to do. For example, NLP means natural language processing, meaning those tasks where the machine learning model is actually, or the AI system is actually trying to process the natural language, the language which we speak, that may be audio, that may be video, or that may be plain text. Okay, so when we are doing such task, we say that this is an NLP task. And then this NLP task can be done by normal, I mean, traditional machine learning models, by deep learning models, and by Gen AI also. These days, this is heavily being done using Gen AI. Okay, and then what is artificial intelligence? As I said earlier, anything, or the actions by machines when they mimic human being, right? For example, we as a human being can see the things and we can observe the things. Similarly, if you build that capability for machines so that they can see the objects in front of them, or if they can analyze the images, the audios and the videos, the driverless cars, right? So what they do, they are capable of observing the things in front of them, or whatever is being fed to it. They can analyze those images, audios and videos. Similarly, we can also hear, right? So if we are, if you have multimodal models, we can actually give the instructions in the form of voice or audio, right? So these are the different aspects actually, uh, which if performed by machine, we say that this is something called as an artificial intelligence. And then we talked about how the things evolved over the time during the 90. So AI is not a new thing. So scientists and people have been trying to build AI systems for past 100 years. In 1950s, what they tried they thought maybe they can create some rules. Okay, so that AI is called as a rule based systems, or the rule based AI, or symbolic AI. So what they thought is, if they can create rules like if else, so one day maybe they will create so many rules that the machines which they are going to build will have capability equivalent to human beings. Okay, so that's what it is called as the symbolic AI or rule based AI. Even today also, sometime we use the rule based AI. For example, the project which I am doing currently, it's basically with for an insurance company, health insurance company. And what we are trying to do is we are trying to analyze if the claims which are being filed by the different policy holders for the health insurance, let's say someone has a visit to the doctor and the doctor has given some prescription, he has undergone some operation. Okay, so end of the day, what he will do is he will take all of his papers, documents, and he will fill an insurance form, and he will do a claim. So the problem statement is how we can find in, uh, the fraud. Basically, there is something called as FWA, fraud, waste, and abuse. So out of those claims which are being done by the different policy holders, the insurance company want to find out if those cases are fraud or not. If there is any cases where the people are wrongly or abusing the system, FWA. To detect the fraud or the fraud detection, what we are going to do is our first approach is to use rule-based AI, where we will create the different rules. Okay, we can say that if the doctor has, prescribed MRI as well as X-ray within a single day, that is a probable case of FWA, fraud, because doctor will never ask, MRI and the CT scan and the X-ray all together. Similarly, so there are a lot of rules which we can build, and we can process our claim data on top of those rules, and we can see what are the potential fraud cases. Okay, so this is basically rule-based AI, where what we are doing, we are creating the rules out of it. Okay, what we are doing, we are creating some rules and we are passing some data. Okay, and what it will do is it will give us the answer. So the main thing is we are also passing the rules along with the data. For example, there is a problem which we discussed in detail, the housing price. So we have various features. So all these are called what? The number of bedrooms, the square footage, and the location. So these are the features, basically the attributes. So what we do, we pass these attributes, and we also decide what should be the value of these weights. These are called weights, W1, W2, and W3. So we are giving the rules, we are defining the rules, and we are also giving the data, and then our rule-based AI will give us the answer. In contrast, in the machine learning, so they tried this thing for a couple of years, and in 90s, I think they built one rule based system which was called Deep Blue. Okay, so this system actually was able to defeat the world chess champion. Okay, I think it was Gary Kasparov at that point of time. So this was the first time when an AI system basically defeated the grandmaster, or the world champion. So this was an example of rule-based AI, where they created this. Deep Blue was a system which was created using rule-based AI. What step, or how it has to how it has to play, basically what are the various permutations and combinations. Okay, so based on those rules, the system was able to defeat the world champion. Okay, so this was the one of those examples. But then soon we came with something called as a machine learning, where we are just passing the data and also the answers of the data. So what we are doing here, we are passing the number of bedrooms, square footage, and locations for lot of cases, and we are also passing the price of the house. Okay, we are not passing, or we are not calculating W1, W2, and W3. We let machine to calculate these rules. Okay, so this is called as the machine learning. So if I look at this diagram, okay, earlier data and rules were passed to the computer, and answer is what we were getting. But in machine learning, what we are doing, this they are switched. Basically, we are passing only the data and answers, and we let computer to find out those rules, those weights it will calculate based on the data which we fed. Okay. And then we saw what are the different AI workloads. We have machine learning, where we train the systems and it is able to, I mean, predict or guess the answer, okay, for the examples which it has not seen in the past. If you have trained a model with a lot of housing prices, then once it is being trained, if we pass it the location and the area footage and everything, it will be able to tell us the price of that particular house. And computer vision is a special branch where we mainly deal with, you know, processing the images, the audios, and the vision. NLP, as I said, it deals with the text, document intelligence, knowledge mining. They are a bit specific to Azure. And then generative AI, where we have the system or the AI system which can create new text, new images, and the new audios and video. Okay. So I just wanted to quickly go through one more time. So I will not spend too much of time on this. Already been explained. So in short, what is machine learning? What we do, we have some training data. Okay, that can be in the form of CSV or that can be in the database. Okay, and we have something called the features. Okay, so X1, X2, X3, these are the different features. These are attributes basically. Okay. For the housing price, this X1 is like the number of rooms, the area, and the location. Location does not mean we are passing the location like Noida, Delhi, or something. We need to convert it into some mathematical form. Okay, so that can be treated as maybe location is score 0 to 10. Okay, so these are the different attributes, and this is Y is our target variable. These are independent variables and this is dependent variables. So our aim is to train the system in such a way so that it can predict the correct value of Y when we just have these input parameters. Okay, so we have the training data. Okay, these are called features, these are called labels. We pass it to some algorithm. Those algorithm can be based on our problem. We need to choose the algorithm that can be linear regression, logistic regression, decision trees, or we can use some ensemble techniques like boosting and stacking and all those stuffs. Okay, so these are the different algorithms which we can use to train our system, and then the model is created. We pass the data, we calculate the loss, we optimize the weights. The ultimate goal of machine learning is to optimize the weights in such a way that we can have, you know, some function or some curve which basically fits into this data. Okay, so that our prediction will be more accurate. Okay, so the model, the inferencing data, and finally the prediction. This is called inferencing. Okay, giving the input and getting the output is called inference. Type of machine learning: supervised machine learning, unsupervised machine learning. In case of supervised, we have the labels. In case of housing data, initially we pass the price of the house which we want to calculate along with my features. So we train the model. That supervised model can be of two types. First is the regression, where the output can be anything, any integer or any numerical value. Okay, for example, the price can be 10 lakhs, 50 lakhs, 62 lakhs, 80 lakhs, 1 CR, 5 CR. So there is no limit. The output can be any numerical value or any continuous value or function. That is called as the regression problem. If we talk about classification, classifications are the problems where my output is well defined. It can be, the email can be either spam or not spam. Okay, the image is either of a dog or it's a cat. Okay, these categories can be more than two also. Okay, there can be 5 categories. Maybe I am trying to identifying the color, so the output can be red, blue, green, or whatever. So again, based on number of categories, if the categories are just two, we say it's a binary classification. If you have multiple classes, we need to find out the species of a penguin, and the number of species are more than 2, 3, 4, or 5, then we say it a multi-class classification problem. Okay, so These are the two broad categories. In unsupervised learning, we don't pass the labeled data. The data is labeled, and we say to the machine learning algorithm will help us to identify the pattern. It will say the if you pass it 10 news articles, maybe it will analyze and it will say there are four category of within these articles. Two of them, two of these news articles belongs to the politics, two to the entertainment, three are the, you know, with the technology, or maybe rest of are the sports news. So what it can do, it can create different clusters. And again, there are a lot of algorithms. You have like clustering, you have other type of problems as well. Okay, so we'll not go much deeper into all these things. They are machine learning in itself is a subject which takes, you know, around 6 months or a year to learn and understand. But I'm just trying to give you some high level overview so that you don't get lost when somebody is talking about machine learning. Another way to look at it, let's say we have these all images, and our what we have done is we out of these images, what we have done is we have created this group. So what kind of machine learning is this? Someone please. What we have done, is it supervised or unsupervised? And if supervised, is it classification or a regression problem? Anyone please.
Classification.
Classification.
So this is, first of all, this is unsupervised learning. This is not I mean, classification is fine, but this is unsupervised learning because the data is not labeled, right? I'm not saying this is a cycle or this is a two-wheeler or this is a bus, this is a car or this is a truck. Am I saying, is my data having any label? There is no labeling, right? This is my input data. And what my machine is doing is based on my input data, it is trying to categorize the data into different groups. Okay, so that categorization, it depends on the algorithm itself. It may be based on the image or the number of wheels or the body of the car, right? So this is a this is a uh,
Unsupervised.
unsupervised problem. Okay, we are creating categories basically. Similarly, if I pass some newspaper articles, it will categorize. These are the sports news. These are the politics news. These are the entertainment news, right? Or maybe if I have a lot of customers, okay, I can categorize these companies belongs to the manufacturing. These are from the healthcare. These are from some different domain. Okay, so like that, I may not know finally how many domains will be created or how many classes will be created. So that all depends how they are different from each other. Okay, so there are algorithms which will help us to find the distance between or the difference between these images. Based on that, it will create the categories. Maybe this uh, I mean, if we use a particular algorithm, maybe it will create three categories. If we use some different parameters, maybe it will say this is looking a bit different. So maybe it will create four categories. Okay, so that depends on your requirement or on the algorithm also. So this is unsupervised. Next, this time what I'm doing, I'm telling the system whatever images I am sending to my algorithm, I'm saying these are the bikes. Look at the image and this is a bike. That means I'm labeling it. I'm saying, I'm giving the output. This is the bike. All these are bike images. Okay, so the machine learning will learn, okay, all the bikes looks like this thing. Okay, so they have two wheels. I will be sending the various images of car. So it will learn, okay, all the cars have these kind of features. The different cars can have these type of features. I will say these are the trucks. Okay, so it will try to see why it is called a truck, what are its features, what is its heights, weights, and all those things. It will try to learn all those things. And then sorry, so this image, this is basically unsupervised. This is in continuation to our last problem. Okay, so I sent number of images. It categorized those images. and it finally said these are bikes, these are cars, and these are trucks. It will not say that these are bikes or not. This is like class 1, class 2, and class 3. Okay, makes sense? This is unsupervised learning. When we talk about supervised learning, what I will do? I will label each image. Okay, and then I pass it to my, and then my question is, what is this image? Okay, is it a car, is it a truck, or is it a bike? Okay, so I have trained my system, and then it will respond to me, okay, this is a car. So this is called as the supervised learning. Model training and evaluation. How do we train? We have a training data. We create two part of it. One will be the training, other will be the validation data. Then we have, again, we have a lot of algorithms. We put, or we train the model with the help of this training data. And once it is being trained and it is able to find the predictions, what I will do, I will test it on the validation data. I will evaluate my model, what is its score. There is something called as the confusion matrix that I can use to evaluate my model. Okay, so this is a generic process. Then again, so we saw the outer circle was AI, the inner is the machine learning. The Within the machine learning, we have a branch called as the deep learning or the neural network. So what are neural networks, or what is artificial neural network? So these are the special machine learning models where we use an architecture which has input layers and output layers and some hidden layers. And why it is called a neural network? Because it is inspired by human brain. The way the human brain works is like, there are a lot of neurons in our brain, and whenever some input goes to it, it basically creates some electrical pulses, right? Some pulses are created in one neuron that triggers the other neurons, and so on and so forth. So these neural networks are inspired by that, but that does not mean it works similar to our human brains. It is just inspired. It is just like, it is analogous to say that the birds are same as the aeroplanes, right? They are quite different, but they are same in the way that they both can fly in the sky. They may have similar shape of their wings. They are aerodynamics, right? But other than that, they are actually different things, right? Similarly, this neural network is inspired by human brain, but the scientists are even don't know more than 2 or 3% of the human brain. So it's just an inspiration. That's all. It's not like that they are actually working like an human brain. They are quite different. That's what I want to say. So in the neural network, what we do, we have a lot of neurons. So when do we use neural networks? We use neural networks when our problem is a bit complex. We have lot of features, number of features like 1,000, 10,000, or maybe in billions and millions. Okay. So when our features are more, or we have a complex problem, this neural networks has a capability to solve those complex problems as well, because there are more number of neurons, or there will be more number of weights, so its size is bigger basically. Just like in the human brain has lot of neurons, so if the size is increases, its capacity to learn the pattern also increases. So when we say there is a large language model of 70 billion parameter, that means it has 70 billion weights, okay, which are being trained. So if you have 70 billion weights, then definitely you can learn more complex patterns, and the more patterns in the complex data basically. Okay, so we have something called as the input fit. This is the input layer. This is my output layer. These are called as the hidden layers. Okay, because you actually don't know what is going inside these hidden layers. Okay, even in case of large language models, if you pass some prompt and you get a completion, you cannot actually argue why that output has came, right? You cannot go back and say, oh, this is because of this particular function. Okay, so LLMs are essentially black boxes. You actually don't know what is going on inside. Okay, so we have input layers, output layers. We pass on the features just like we do in the machine learning, and then we get the output. Okay, so this is the class 1, class 2, and class 3. So answer is actually produced in the form of probability score. Okay, the probability of this image being belonging to the first category is 0.2, second category is 0.7, the third is 0.1. So the final answer will be 0.7. This image belongs to the second species of the penguin. I hope I am making sense, guys. Talking too much. Are you getting, guys?
Yeah, it does make sense.
Yes.
Yeah.
Yep.
So this is how it is being trained. Okay. Uh, Neural network. So I have taken a lot of, I have done a lot of research. I have taken whatever photos I thought may be helpful for you guys to understand these concepts. So in case of neural networks, what we have, as I said, we have different layers. Okay. Within those layers, what happens? Some data transformation happens. So in these neurons, there are some activation functions. I don't want to go deeper, but still let me tell you, there are some activation functions like sigmoid functions or ReLU functions, or there are a couple of more functions. So we use those functions. These values are passed, some operations happen or some transformation happens on these neurons, and then it is passed to uh, next neuron. Okay, so the one neuron connects to all other neurons like this. So we have like weights, weight 1. If this is layer 1 and layer 2, this is like weight 1, 2, weight from 1 to 2, weight 1, 3, weight 1, 4, weight 1, 5. From the second neuron, it's like weight 1, 2, sorry, weight 2, 1, weight 2, 2, weight 2, 3. So there are a lot of weights basically. Okay, everyone connects to the every other neuron. So what happens on the layers? The data is being transformed. Some linear operation or some other operations happens on that particular value, which is being passed to a neuron. So our input X, data transformation at the first layer, data transformation at the second layer, and we get some output. Some of the predictions happens. So on top of it, what is our goal of training a model is to find the optimum values of these weights basically. Okay, we have to find the optimum value of these weights so that my predictions goes right. So how do I do that? What I will do, my input X will be passed, there will be some weights, there will be some transformation. So the transformation when happens, it's like W1 12 into the input feature plus W1 12, something like that. So the transformation is dependent on the weights as well as on your function, activation function. Okay, so it will do some predictions. Initially, when you start training, these weights are randomly decided, right? It's not like that these weights are zero. If they are zero, then your output will also be zero. So the machine learning algorithm randomly gives some values, maybe 0.1 to this one, maybe 0.3 to this particular weight. Okay, so they are randomly initialized. When you pass the data, some prediction will be done. So what do you think? Initially, when the prediction will be done, is it going to be right or wrong from the actual prediction? That will be very far away from the actual results, right? Okay. When I say this is my housing data, I randomly initialize my weights. I pass it. This is the number of rooms. This is the area, and this is the location score. And you tell me the price of this house. So what it will say? It will say your price of the house is 10 rupees. That is, there is a lot of error right now because these weights are not optimized. Okay, so the predictions will be very wrong initially because our system is not trained. So what I will do, since I know, okay, for this particular data, the price of my house is 50 lakhs. The actual output is 10 rupees. So what I will do, I will calculate the loss. How far away my prediction is from my true target. Okay, so there will be a loss function. I will take that loss function and I will calculate my loss score. This is amount of error I am getting. But the question is what I should do with that error. Okay, I have calculated the error or the deviation of my current system from my ideal system. Okay, now what I need to do with this score is I will use some optimizers. Okay, so there are again some libraries which give us some optimizer. I will use those optimizers to update my weights. see, my main target is to update the weights in such a way that my system should do right prediction. So what I have to do is I have to, after every iteration, it is called epoch. When I fetch some data, it will pass through my neural network. It will produce some result. Okay, then I will go back to my different layers. I will update those weights. Okay, so that my system become optimum. Okay, so what these optimizers do, they see, okay, there is a loss, and they actually know which weight has contributed to more loss and which weight has contributed to less loss, basically. So accordingly, it will change those weights in such a way that next time when the data comes, my loss will be reduced. Okay, so this training goes and goes on. Okay, so I have a lot of data, so I keep on training my system, and it keep on updating the weights, and finally a time will come when my loss function will be very minimal or is about zero. At that point of time, I will say, okay, my system has been trained, my weights are adjusted in such a way that my system can make right predictions. At that point of time, I will stop my training. And then if I give some data which is not being seen by my system, unseen data, if I give some features of a house, it will be able to tell me correctly the price of that particular house. Is it making sense, guys? How it is being trained and how it is able to predict the prices.
Yes, yes.
सब कुछ ठीक है, बढ़िया चल रहा है?
Yeah, I mean, at a high level, yes, definitely. I do want to know more about the optimizer, but probably not current scope, probably.
Yeah, I
That's okay.
mean,
Yeah,
there are
that's okay.
optimizers like grad optimizers or couple of optimizers. So I mean, they are just piece of libraries. Okay, so there are couple of optimizers. Let's say A, B, and C. So you have to decide which optimizer to use. Okay, so if I go into depth, it will take.
No, that's okay.
Yeah.
But just a high-level question, like on the previous one, let's say when you're calculating the loss function, right? Or rather, the system is calculating the loss function, like from your true targets, how far is the prediction? How, like, how is the loss score not able to put the question correctly, probably. So, like loss function, let's say I have 90%, 98% deviation, for example, right? Like you're saying 10 rupees versus it should have been like 98 lakhs, probably. So now how do the optimizer knows which weights to be increased?
Right. So I will go back to our 10th class mathematics, where what we used to do, we have some function y, okay, and then we have to find if in that particular equation y is equal to something x plus something, I mean there is some equation. Then in order to find out the contribution of each weight, what we used to do is we used to differentiate that particular equation with respect to W1. So this equation will be have weights, right? Because we have calculated the loss with the help of these weights. So when I differentiate that function with respect to W1, how that loss is changing with respect to one weight W1.
Got it.
Okay.
So it basically
yeah,
varies the weights and varies the calculations,
exactly.
and based on that, it goes closer and closer to the true target.
Closer and exactly.
Okay. Okay. Thanks.
Okay. So it's like you can look at it. Let's say I am in a valley. Okay. So this is my loss curve, maybe. Okay. In a U shape. So what this is my loss function. So what, let's say I am right now here. So my aim is to reach at this point where the loss is minimum. Okay.
Got it.
So what I will do is I will change my weights a little bit. So we'll see, let's say I have increased my weight, then I reach here basically. Then I will calculate my loss. I will say, okay, is my loss increasing or decreasing? Oh, it's decreasing. That means I'm going in the right direction. If my loss is increasing, so I will have my loss being increased. So that kind of algorithms are also there, which will find, it will try to calculate all these things, weight, how much is the weight. And then at some point of time, it will see after changing the weights, my loss is again increasing. That means this is my optimum point. Okay. So there are a lot of things. This curve can be something like that also. So in this case, it will see, okay, by changing my weight, my loss is actually increasing. So is it my minima? No, this is not my global minima. My global minima is this one. So what I will do is I will keep on training my system for maybe more 100 cycles. When you send some data, and when there is an output from my neural network, this is called one epoch. One iteration is called one epoch. So I say, if by changing my weights my loss is increasing, so I will still continue for the next 100 cycles to see whether is it continuously increasing, or maybe after 80 cycles it will start decreasing. If it is the case, then okay, that this minima may be a local minima, not the global minima. So there are actually a lot of things which are going in the background. Okay.
Okay. Yeah,
So
got it.
yeah.
Yeah.
Okay. So this is how we calculate. Okay. If we talk about the analytics, right? Since we have been talking, we are emphasizing a lot of, on how the machine learning, how does it works. So there is a process, right? If you want to solve any such problem with the help of machine learning, if you want to train a model, so this is the approach basically. We have a business problem. Let's say the business problem is to calculate the price of the house. Then whatever data which we will get, first of all, we have to define our problem. We have to collect the data, right? We should have some data of the houses, right? Then only we can train our system. So we will collect that data, we will do some data processing. So the data which I will receive from the different system may not be in right syntax, or that may not be clean. So what I need to do is I need to clean it basically, right? So let's say I have got some data and it is saying that the price of the house is 1000 crore. So that is an outlier. Okay, so I need to process the data to make it clean so that we can train our system. If we train our system with the wrong data, what will happen? My system can never predict the right thing. So I have to remove some outliers, and I have to do a lot of data processing. Okay. So once I prepare my data, I do EDA, exploratory data analysis. EDA means what? I will plot different type of graphs to see which parameter is actually influencing my price of the house. Is it the area? Is it the location? Is it the number of rooms? Okay, all those things. So this is also where we do some feature engineering. Maybe we will club two columns into one column, two features into one feature, and I will basically plot different graphs to see how the story inside my data. Okay, to get some insights from my data. And then I design my problem, I do modeling, I train my system, I do experimenting. Okay, so this is an iterative process basically. I can go back to my data preprocessing. I can say, okay, make these two columns are saying the same story, so make it just one. So like that, there is some iteration. I can do some experiments, and if something has gone wrong, maybe I need to go back to my first stage. I have to redefine my problem, and it goes and go. Okay. So once it is being done, my model is being trained, it is performing well on my test data. What I will do, I can go for the deployment. So this is a very at a high level how a machine learning or these problems are tackled. Okay. Training models. So I have these problems. I have collected some data, and this is what I can show you on screen. But let me know, do you want me to cover the rest of the session first? Because otherwise we may not have some time to complete this one. We have a lot of decks actually, and we are actually deviating a lot. So maybe let me finish my today's agenda, and then in the end I will show you how to train the models. Okay.
Yeah, let's do that.
Okay, so this also we have done. What is the reason of the sudden boom in the AI? Right? So these are the regions: the availability of lot of data, lot of compute power, and the innovation in the machine learning innovation, like the the release of the transformers architecture. Those machine learning algorithms have also got advanced. So couple of reasons: what is generative AI? Creates new content, ideas, all those things, right? If we are creating some new text, images, videos, and music, this is all about generative AI. Why the foundation models? are not preferred over LLMs because we have to train them specifically for a task. But in case of LLMs, the best thing is once they are being labeled, they can do multitasking. Our GPT models can do text generation, they can do summarization, information extraction, Q&A, and chatbot. Lot of things it can do, right? So that's why the entire world is running behind these large language models, okay, instead of these traditional machine learning models, which are very specific. And sometimes there are teams who spend 6 to 8 months in training a model, and end of it, they feel like, we are going nowhere, there is some issue, and they are not able to accomplish their aim. That also happens, and the project gets scrapped. Anyways, so now the important thing from the perspective of machine learning is called inference. What is an inference? As we talked about in case of housing problem, we are giving the input to my model and I am getting some output, right? So that input is basically, uh, this entire act is called as the inference, where I am passing some input data and I am getting some output. So this is not specific to my LLM, but this inference term is very much being used in the machine learning, deep learning, in all those fields. Okay. But in case of LLM, my input is actually called as the prompt and my output is called as the completion. And this entire process is called inference. Okay. If there is a, on the Hugging Face, if there is a meta model, if I am sending it some text and it is giving me as an output some text, I say I have inferenced the Llama model. Okay. There are some some operations which are being done in the middle. For example, when I pass my prompt to the large language model, so my prompt is what is capital of India, then that will not be passed as is to the language model, right? I have to convert it into some mathematical form which LLM can understand. So there is one layer in between my prompt and my model, which is called as a tokenization. I convert the words into tokens. This we will read more in the coming slides. But yes, at a high level, we have couple of transformations taking place in between my input and my language model, and my language model and my completion. Okay. Prompt is the input text to the model, completion is the output text generated by model, and inference is the process of generating a completion from prompt using a large language model. Fair enough. So now the question is, give me 1 minute, guys. Let me grab some water. Yeah, give me a second. Okay. So the question is now, what is large language models? Okay. So these are the neural networks, just like we studied, right? We have neural networks, we have inputlets, outputlets. So those neural networks are there, but they basically follow one special architecture which is called as the transformers architecture. So there is a paper, right? Attention is all you need. You can go through that paper, you can download it from internet, and if you are interested, you can go through that particular paper. It will have all the details how this architecture works. So this was an architecture which was being released by Google researchers in 2017. Okay, and why this was very special? Okay, the reason being, it was able to, it has basically, first thing is, it has this multi-head attention layer. Okay, with the help of this multi-head attention mechanism, what it was able to do, that it was able to understand the even the larger context. Okay, if I pass 20 lines or 50 lines or 100 lines, then also it was able to understand those contents. Okay, so the earlier models, so like your RNNs, there is something called as recurrent neural network, there is something called GRU, there is something called LSTM. So these were the models which were being used before the transformer came into the world. They were being used for NLP task. Okay, but they had some shortcomings. They were not able to understand the long sentences. Okay, so if you feed them 10 lines, so by the time it processed the 10th line, it was forgetting about the first, second, or third lines. So that was problem with memory. Okay, but these models which are based on transformers, on transformer architecture, they have some specialty that they have multi-head attention mechanism which help them to understand the larger content, one page, two page, three page. In the chat GPT also you can see, even if you paste some hundreds of lines, it will be able to go through those lines, it will be able to understand those lines, and then it will reply. So what is this multi-head attention? So this is a special mechanism where whatever content or whatever text we pass it to the model, it will decide which word is more important, where it has to do more attention. Okay, let's say there is a sentence called Ram may go to Ayodhya in May, in the month of May, right? So this is a very complex sentence because there are two May, M-A-Y. Ram may go to Ayodhya in May. Okay, but if you pass this sentence to the earlier models, they may make some mistake. But in case of this transformer architectures, what it will do is it will pay more attention to the words which are more important, and it will try to evaluate each word with respect to the other words. What does it mean? Okay, so it will, try to answer some questions. Who is going? Okay, Ram is going. Where he is going? He is going Ayodhya. When he is going in May. So there are multiple heads, multiple perspective in which each word is compared to the rest of the sentence and its meaning is calculated basically. Okay, so that's at a very high level. So these are the architectures which solve a lot of problems which earlier models were facing, and it was able to process the larger content basically. So now the question is, what is LLM? So LLMs are trained on large corpus of text data for the weeks and months. They are able to predict the next token. So they are nothing but they are some mathematical calculators, you can say, or statistical calculators. Okay, so what they will do is, if you give some data or some text, what all it will do is it will try to predict the next token. Okay, if you give a sentence, it will guess what should be the next probable word. This is how they generate the text. Okay,
Suryan, this transformer model is only for a specific text data or audio, video, and image also?
everything. Now it has been used for all type of models.
Okay.
Okay, so it predicts and guess the next token, then repeat the process until the completion. Built using the transformer architecture, transformer outputs a probability distribution. So you can see in the end, so there are two part of it. One is the encoder and other is the decoder. In the decoder, the last component is the softmax. So this softmax layer does what? It basically outputs a probability of the different words. As I said, the main aim or the main task which a model performs, LLM perform, is to predict the next token. For the given sentence, what should be the next appropriate word. So what it will do is it will give you an entire list of words with its different probabilities, and it will see which word is having the maximum probability. Okay, and it will choose that word and it will append to the input sentence, and that input is again passed to it, and then it will predict the next
So,
token. Yeah.
so Surendra, how is this different from what Google has been doing for last 10, 15 years? If you are searching, it will try to autocomplete and everything, right?
Mm-hmm.
So how is this different? Like if it's just guessing the next, or not guessing, but rather calculating or intelligent guess, the
Huh.
way you can put it,
Right.
right? So
So, I
that
mean, it is different because it has something called as the multi-head attention. So now whatever text you pass it, it will be able to create the different weights and different meaning of those words with respect to the other words. Basically, in short, it was able to understand your input sentence more precisely. Earlier, the models were not able to understand them very clearly. So they were giving outputs, but they were struggling at some point of times. Okay, for example, RNN, recurrent neural network, GRUs, your LSTMs, long short term memory. So these were the models which were used earlier, but they were not, they had some shortcomings. If you pass them a lot of data, it will not be able to understand that data. Okay, so
okay.
the only beauty is the multi-head attention. So there is some K, Q, and V. There is some mathematics going on behind the scenes which will help them to understand the data more appropriately. They will not hallucinate, or they will not confuse between MAY, month may, and the other may, I may go, right? MAY. Because it also study the words preceding and the words next to that particular word. Okay, then it is able to guess, okay, this May is
So
not the month.
basically,
Hmm.
more contextual.
Exactly, more
Okay.
contextual, that's the right word.
And it's kind of a buffer also. He has maintained the buffer from previous to next one, like this one.
Yes, I mean, you can say it is able to retain whatever is being talked about in the first line, second line, third line. Okay, if you have a large content, maybe of 20, 30 lines, still it will be able to make out of the entire sentence. Earlier, what was happening is when it is going through the 10th line, so what it does is when it is going through the first line, it creates some, some weights or some meaning out of it. But as the sentence, then the number of words and number of sentences increases, that particular memory is getting faded in the earlier models. But this one is very good at it. Okay, so the transformer outputs a probability distribution that I have told you with lots of compute power, and there's a lot of compute power. As I said, this actually needs a lot of compute power. These companies are actually, you know, purchasing the old nuclear power plants so that they can give power to their training data centers and all those things. Okay, right? So they take a lot of power, lot of electricity consumption is there. The carbon footprint is too much. It's not an easy job. Okay, so and the parameters, as I said, the parameters act as the memory of the LLM. When I say the large language model is 4 billion, 7 billion, 70 billion, those many are the parameters, basically the weights which are there. The more number of weights, more memory it will have, more different data structures it can understand and store. Okay. Now, let's talk about furthermore about this particular transformers architecture. So it has two parts. This left hand side is called encoder, and the right hand side part is called as the decoder. So what it will do is the encoder part converts input sequence to hidden states. Okay, takes input text and creates a numerical representation, vectorize of the text and position it in a semantic field. So you can see this is my input. When I send one sentence to pass the one sentence to my this architecture, what will happen? First of all, these won't be able to understand our natural language. Correct? If I say, why did the chicken cross the, first task which it will do is it will create embeddings of it. It will convert those words into tokens. Okay, tokens are nothing but maybe this first word will be converted as one token, will be treated as one token. Second word as also another token. The also token. Chicken maybe chick will be one token. En will be another token. Okay, so that depends what tokenizer or what library I am using. But all it will do is it will convert my sentence into different tokens, and one word may result into one token or maybe two tokens. Okay, roughly it is said that one token is equal to 3/4 of a word. Okay, for example, in case of hidden, what it will do, maybe it will take hide as one token and en as the second token. Okay, again that depends on the library. So what it will do, it will take my sentence, my raw data, it will convert it into different tokens, and all those tokens will be given some numerical values, some numerical or mathematical values, so that we can pass that numerical values for doing the processing. Okay, my model does not understand the language itself, right? I have to convert it into some mathematical format or numerical representation. This is what this particular box will be doing. The next is the positional encoding. So now when I convert my sentence into some mass, maybe it will be like 1, 2, 3, 4, 5. Now what will happen when I pass these numbers to this particular layer? What it will do is it will do some indexing kind of thing. Okay, this first token is coming at the first time, second time, third time, sequence basically. What is the sequence of the words? Okay, also it just came into my mind, these models transformer models are better than the earlier models because these models can actually do parallel processing also, meaning I can pass the entire sentence in one go. Earlier the models were, they used to process word by word. I have to pass the first word, second word, third word. So we were not it was not confused of the sequence. But since here we can pass the entire sentence in one go, it will create some positional encoding. It will create some indexing. Okay, this is my first word, second token, third token, fourth token, five token, and all those things. And then I pass it to my this multi-head attention layer, where it will try, this encoder part will do what? It will process that particular sentence in such a way that once it come out of the first encoder part, it will have good representation of that sentence, good representation in some sense, so that my decoder can understand what the sentence is all about, what is attention of each word with respect to the other word. Okay, so this encoder part basically help us to understand the sentence which is given as an output, and this decoder will help us to generate the new tokens based on my input tokens. What it will do, as I said, they are nothing but help us to predict the next token. When I pass this input, why did the chicken cross the, it will be able to predict the next token as the road. Okay, it will say road has the highest probability in this context. Okay, so this is how basically, and once it passes the road, once it is able to generate the road will be fed again to my, this is output, right? Whatever output I get, I will fed it to my decoder, and again it will try to predict the next word after the road. Okay, maybe the next word is like question mark. It will generate the question mark. Okay, the most appropriate word after this particular sentence. Why did the chicken cross the road? And then question mark. Okay, so this is
Surendra, what I have learned about some model are use only decoder. Some use are decoder and decoder both.
Exactly.
And some how it differentiate
So
what would be
that,
the
yeah, I mean that basically depends on your use case. For translations, maybe only encoder is sufficient, and for doing question answering, maybe encoder decoder is being sufficient. So there are different flavors, different model creators use different architectures. Some use only encoder, some use only decoder, some use encoder plus decoder. So that is basically on your use case for what you are training your model.
okay.
Okay. So if you want to learn more, definitely you can go to that particular research paper and you can go through it. Okay, that explains a lot of things. But for us, I think this is sufficient. That transformer is one of the state of the art architecture, and it is able to solve a lot of problems which earlier models were facing. For example, the longer context and parallel processing, and it does not hallucinate much. Yeah, so these are some of the features of the transformer whatever models, even today the models which are being released, they are based on transformers. Okay, so it was one of the major breakthrough in the technology.
And what about this DeepSeek? It's also for transformer model?
I think, see, not every model will release their details, how it is being trained because of their own. But yes, all these models are based on transformer only in some or other way. I mean, they may change little bit here and there, right? That's why the DeepSeek model is being said that it has been trained with a very low cost, maybe around 1/10 of the cost of what OpenAI used to train. So maybe they have, tweaked little bits or, something here, I mean, here and there. So that they never reveal actually how it is actually trained, what data they have used. So they keep it very confidential. Okay. So I was able to download that DeepSeek also on my the 7 billion parameter model. It was actually working, I mean, pretty nicely. Okay. I compared it with Llama 3.2, 3 billion. So it was definitely better than that. Anyway, so the takeaway from this transformers architecture is that how these models actually predict the next token. This is what I want you to understand. So when I say why did the chicken cross the, my model or LLM will predict the next token road, and then it will try to complete this sentence. Okay. Why did the chicken, what it will do, it will split the sentence into different tokens. It will convert into some mathematical form. It will pass through the two layers, and then it will predict the next token. The road will be again passed to my decoder. It will try to guess the next token. It will guess, okay, the question mark should be there. So this is how they actually internally work. How LLM select the next token? As I said, they have this layer in the end. You have seen, this is the softmax layer. And what they will do is, model uses softmax function to output a probability distribution for each word in the vocabulary. Okay, so when I use my tokenizer, this tokenizer is here actually. So let's say this tokenizer is also a model actually. Okay, it's also a neural network. So it is also being trained on number of words. Let's say after its training, it has a dictionary. Okay, it has been trained on 1000 words, 1000 different words, this tokenizer. So the same tokenizer I have to use at the time of output. And this softmax layer does what? It will create the list. It will produce a list of the different probabilities of those 1000 words. It will it will be equal to the total number of words in my dictionary. Okay, all the dictionary, all 1000 tokens or the words will be I mean produced by the softmax layers with their probability score. Okay, and if you, as the rule of the probability, if you sum all those probabilities, it will come out to the 1. Okay, so now it will select the word which has the highest probability, or you can say the chances of road being the next word is 20%, for the river is 10%, house is 0.05%. Okay, that again depends on some parameters which we will discuss in next slides. Okay, model uses a softmax function to output a probability distribution of each word in the vocabulary, whatever dictionary it has. It will create the list of, it will produce that list, and it will append the probability score against each token or word. Example input, why did the chicken cross? The output is road is 0.1, river 0.05, forest is 0.03, mountain is 0.02. Because it is being trained on different kind of data, based on its training, it will see, okay, as per me, the road is the most, I mean, probable word and most eligible word as a next token. I hope that makes sense. And then now we are moving to the various generative configurations. Any questions so far? I will take a pause. Okay, so these are the configuration probabilities which can alter your output. Take these configurations with a pinch of salt, because when I build applications in my company, I usually don't use all of these. So they are there, but most of the time we don't alter them or we don't change them. So this is just for your knowledge what these configurations are all about. You should know. That's it. When we are using APIs from OpenAI or from Google models, we don't actually play with all these configurations. But the only thing which we generally change is the temperature. Okay. Otherwise, we pretty much keep the settings, the default ones. Okay. So the first setting is the maximum new tokens. So if you set the token limit as 100, the maximum new token, this if you set this property as 100, what it will do is it will generate only 100 tokens and it will stop after that. Okay. When I say my maximum new token is 150, then it will only generate maximum of 150 tokens as an output. Okay. If I say my limit is 200, and if my answer has completed after 100 tokens, it will stop basically. It's not necessary that it will go on and generate 200 token exactly. Okay. So this is the upper limit. Why there is a limit? Let's say there is a provider which is an open source model, and they have, let's say, OpenAI, which is a closed source. They have hosted their chat gpt functionality, right? You can use chat gpt application to influence their models. What if you keep on using the model, you say write an 1000 page long answer or essay on some topic, so you will keep on using that model, right? You will abuse the system. In order to avoid that, what they can do is they can put some kind of restriction so that the people don't overuse it, or the users may not use it more, so that it should, so it should not increase the cost too much. Okay, so this is an upper cap on the maximum number of tokens basically. Okay, the next is like there is something called as the sampling strategy, which is like greedy versus random sampling. So what does that mean? Let's say my softmax layer, the outermost layer, has produced these words. These are the words in its dictionary. It will say the cake has 0.2 probability, donut has 0.1, banana has 0.02 and 0.01. So when I set my configuration as greedy, what will happen is my system will always pick the word which has the highest probability. In this case, it will produce cake as an output as my next token. The word or token with the highest probability is selected if my strategy is greedy. If my strategy is random weighted sampling, what it will do is the probabilities of different words will be like the cake will have the probability of being selected as 0.2, means 20% of the time cake will come out as an output, 10% of the time donut will come, 2% of the time banana will come, right? It will select a token using a randomly weighted strategy across the probabilities of all the tokens. Okay. To be very frank, I have never used these strategies. They are just theoretical concepts. Okay. So just keep in mind, we have something called as the greedy and the random sampling. If I want my output to be always selecting the word with the highest probability, then I should be using greedy. Okay. There is something called as the top K and top P sampling. What does the top K means? My final selection of the token will be based on only on top 3 tokens. So in this case, what will happen is, even if my apple is having the probability of 1%, but it can be selected, right? 1% is also a chance. Maybe in 100 cases at one time, my output will be apple, because this also has some output, I mean, probability. Yes or no? Right? But what I want is, I see that, since this is having very low probability, I don't want apple to be an output. So what I can do is I can restrict the tokens which are eligible for my output only to maybe top 3. I want whatever the top 3 tokens are there, the top 3 with the highest, probabilities, the output should be selected only among those. I don't want something absurd answer. So I can say K is equal to 3. Select an output from the top 3 results applying randomly weighted strategy using the probabilities. Make sense? The another way is using the top P. What the top P will mean, if I say my P value is 0.3, then what my system will do is it will add the probabilities of the tokens and it will stop at the place where the P value increases more than 0.3. The cumulative probability basically. If I say P equal to 1, that means all the words, anything can come as an output. If I say P equal to 0.3, then 0.2 plus 0.1 is 0.3. So it will select the word only out of these two. Okay, it will never select banana or an apple because my cumulative P is 0.3. And if I add this one, it will be 0.32. So I will rule out these options. I have to choose only out of these two. Make sense? So they are just different ways. We don't actually use them. They are just ways. This is for your FYI. The yes, temperature is what we generally use, and it is also being asked in sometime in the interviews also. What is the role of temperature? So what the temperature will do is, cooler the temperature means we are close to 0, and higher the temperature means we are close to 1. Some models use 0 to 1 as a limit, some use 0 to 2 limit. Okay, temperature can vary from 0 to 1 for some models, and for some other models it can be from 0 to 2. If my value is close to 0, that means what it will do is it will strongly peak the probability distribution. Peak means the science, the cake which was having the 0.2 as a 0.2, it will peak this distribution in such a way that the words which are having the highest probability, it will further increase. It will peak basically. Okay. So my system will become more deterministic. It will be very peculiar about the words which will be generated as an output. Whereas if I increase my temperature, what will happen? This distribution will basically flatten. Okay, the difference between these words will decrease. It will narrow down. It will be broader, flatter distribution. Okay, so where do we use which? Okay, this is an
So,
example. Yeah.
Jiten, there's a question. So, low temperature is always gives a good a good probability.
Yes, it will
And
be more accurate, more precise. I will give you examples where to use which configuration. Okay.
okay.
I will give you examples. So the same example which we were doing earlier, why did the chicken cross? If I talk about this top K, if these are the probabilities, road has the 0.2, river 0.1, house 0.05, top K will mean top K equal to 3 would mean it will choose only out of these 3. If my top P is 0.37, it will add 0.2 plus 0.1 is 0.3, 0.35 and 0.37. In that case, it will also include this one. So it can give in output out of these 4 words. Okay, so that was on top P and top K. If I talk about temperature, this probability of 0.2 will increase. It will peak basically, and then it will become 0.6, and my distribution will be more peak basically. It will create the peaks. The difference is exaggerated basically. If my temperature is close to 1, it will flatten my curve, and the probabilities will be more or less similar, or the difference will decrease basically. Someone is trying to ask something?
Yeah. Actually, I have a doubt. Suppose you are telling P and K concept. P and K concept. What is P and K? K is basically taking top 3 models, top 3 probability, right?
Right.
P is taking, calculating the value. If the value is matching up that time, it's taking that, right? Then,
P is like the cumulative probability. It
yeah.
will consider only the
So
tokens.
basically, K is you sort out all your probabilities from top to low, like high to low. and then you define your K as top 3 or top 4 or top 1 or top 2, whatever it is, right? And as top 3, as you were saying, cumulative probability means, let's say I'm saying cumulative probability of 40. So I'll again sort them out and then add all those things. When it is reaching 40 or when it reaches 40 or when it is just crossing 40, I'll stop at
I
that
will stop.
point.
Exactly.
Yeah.
No, no.
100%.
Yes, my question is now how we can decide. Suppose obviously as human we are taking most probability which is taking 1, 2, 3 or 4 in order wise. Suppose probability is from highest one, right? Top one. So when we defined it like O is for P, normally we are taking K, right? It's maximum. But which the cases where we are taking P concept, like we need to calculate the answers and we need probability
Got
of
it. Yeah. So the answer is in the next slide. Okay. So I mean, as I said, generally we use the temperature configuration. Okay. So temperature low means the probability of selecting one word which is having highest probability will increase. My answer will be more accurate and more precise. So when I will use low temperature, so these are the examples. First of all, the pros, the model is more confident in its top choices. The results are more deterministic. If you run your system again and again, your output will be almost same. Okay, I don't want to be creative. I want to be deterministic. For example, I need to, I'm with my application, I'm creating my SQL queries. So I don't want to be creative at that point of time, right? I don't want different answers. I want the SQL query, which is the most appropriate. The table names, column names should be very precise. So I will keep my temperature close to 0. I don't want some creativity out there. On the other hand, if I am writing a poem or I am writing a story, what I will do each time I would like to write some different stories. I want some fun in my content. I don't want the words to be very precise, right? So in that case, I will be increase my temperature to close to 1. So that depends on your application which you are building and your needs basically. And some point of time you may have to experiment the temperature. Maybe you need to do Hittel trial and you can see which temperature works the most for you, what value works right for you. Okay. But to give you an example, use a low temperature setting for applications that do not require creative generation, such as generating MySQL queries. If you are in a healthcare or if you are generating something which is, related to the health or diagnosis, you don't want to be creative, right? You don't want your system to say he's suffering from cancer type A, and the next time it says cancer type B. You don't want to choose from different probabilities, right? You want always the answer with the highest probability. Is it a cancer of type A or a cancer of type B? I don't want to experiment. It's a healthcare application. Or if you are working on a finance application, banking application, I don't want to be creative either in that case, right? So my answer should be very precise and correct. At that point of time, I will use my low temperature. And high temperature means I'm doing something creative. I am generating images or I'm generating, let's say I have built an application where I want to name a restaurant. So I want, it should not give me same answer, right? This is the name of the restaurant you should use, right? Let's say I say I want to name a restaurant. The restaurant deals with, some Thai food. So it will give you some name, right? It will say ABC should be the name of your restaurant. I don't want it should again and again say ABC, 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 ABC. I want some creativity, right? I want it to give the responses more creatively.
Yeah, sorry for interrupt. I got your concept. Like suppose temperature 0 means it's lowest temperature always keep up or down the sun like top one, right?
Right.
And if increase the temperature like 0.1, 0.2, it's coming down. The probability come down. That scenario is completely clear, and then P concept also clear. Now my question is now how I can train my models, how I can train my machines, where it's artificial tech, right? It's I need to train them which situation it is go like temperature basis. For example, you are telling if temperature is low, then it is taking highest number of probability. If temperature is high, then it is take low the probability. So in that case, I think for my situation, I don't take P because if I need K, then it is take always high temperature. So it is temperature is 0, then it is taking from K scenario. Right?
Correct.
Extra, like when I need extra answers, I need extra probability, then I just increase my temperature. Then it is the next probability from down. Then
Right.
how we are choosing P?
That's what I'm saying. That is the reason why we don't play with P and K. We just use temperature as a setting for our configuration. We don't play with P and K and other settings because this is sufficient to create our random answers or more accurate answers. That's why we generally play with temperature only.
Yes,
Okay, so in some cases there is definitely some difference, but we don't want to go up to that detail. Okay, generally we alter only the temperature. So when we are creating the instance of our model, we will see in the code, we can define T is equal to temperature equal to 0 or maybe 0.1 or 0.2. Okay. And we don't play with P and K usually.
Yes,
okay.
Yeah, thank you.
Yeah. So now
there's a one question, Suren, but sometimes what we have seen, if key value is very less, then we are not getting our answer. If we have increased the k value, then we get the more chunk and we'll get our answer of specific questions. Is it like that?
Can you come again?
For example, we have set a k value, like k is a 2. So we are getting the only 2 chunk like this one, correct?
No, chunk, and you are talking about RAG?
Yeah, if you talk about k value also in RAG there. So that is the different and it is the different one?
Yes, they are different one actually. I think you're talking about RAG applications. That is a different thing.
Okay.
This is at the token level from the LLM basically. You are talking about vector database, right? So that is a different thing.
Okay, so both k are different. Okay.
Yes. Okay, now the next part is how these are trained basically. So we have seen the architecture of LLMs, how they predict the next token, okay? And what is going under the hood. We have encoder, we have decoder, sentence goes into, convert into vector representation, and then send to the decoder, it generates the next token. This is how it works. It's basically LLM. When you think about LLM, it should come into mind, it's a text to text machine. Give some text as an input, produce some text as an output. That's it. Now the next topic is how they are basically trained. So they are trained how that they generally take lot of data from internet or maybe from some digital library, from Wikipedia and other sources. They collect a large corpus of data. We're not talking about gigabytes. We are talking about petabytes of data basically. And they clean that data. Okay, they make it in a form which can be used to train these models. And then generally, if they are collected 10 petabytes of data or 100 petabytes of data, only 1 to 4% is actually used for the training. Because this training is so important and your data's cleanliness and bias is so important that it is really a difficult job to prepare the data for any training. Okay, so because whatever data which we are preparing or on which we are training our model, if that is somehow biased, that says, okay, in some sense, it is kind of favoring, if the articles, let's say we are passing some Wikipedia articles, and if those articles are talking about or favoring, maybe some political party, and it's somehow it is biased, it is inclined towards one thing, then my system will also behave in the same way, right? So I have to be very cautious when I'm training my model, large language model, because everything depends on the quality of my data. That is why it's a very tedious job to collect this data and to make sure your data is not biased. So I take a lot of data, and this is called, pre-training. The first time when I'm training my neural network, this is called pre-training. Okay. And this is basically unsupervised. In the sense, I collect a lot of data and I pass it to my neural network. I keep on passing it to my neural network to do it a next token prediction. It will keep on doing next word predictions and it will train itself. Okay, so that's why our data is not labeled. This is called as the unsupervised learning. And the performance of my pre-trained models depends on two things. As I said, the text corpus, the amount of or the quality of my text, and my model sizes. If my model size is very big, that means it has more weights, it has a lot of memory, and it can learn very complex patterns. Okay, so the and the text, as I said, should be cleaned. It is taken from website, books, articles, and Wikipedia and things like that. So let me read it out. Initial phase where the model, what is the pre-training? Initial phase where the model learns from a large corpus of text data, learn general language patterns and structures. So what it will help is pre-training will basically give the model some intuition about how the language works, what are the different words, what are the different tokens, how they are related. It will generate some initial capability to understand the text. Okay, so general language patterns, what are the patterns, how the language is written, what are the different words, how it is being used. And second thing is data, massive data sets. As I said, task is the on which task they are being trained, predicting that a word in a sentence given its context. This is unsupervised learning. Okay, I will give this sentence, it will predict the next word. I will give another sentence, it will predict the next word. Like that it basically happens. Captures wide range of language knowledge, creates versatile base models, requires substantial computational resources, may contain biases from the training data. Okay, if my data is biased, that characteristics will go into my model as well. Okay, so it takes huge computational cost. You have to use lot of hardwares. NVIDIA is one of the company who is producing such TPUs and GPUs, which are being used as an hardware to train these data. When the DeepSeek model was released, they said that, uh, it, they were able to train it on bare minimum hardware. Okay, so that didn't use lot of high compute cost, and the cost was about 1/10 of what OpenAI used to train their models. So that is the reason why the share of this NVIDIA, who is a chip maker, that drastically fall the next day, right? I think 10-15% and NVIDIA share lost the capital market, and there were huge, I mean, losses, because that company is generating a lot of chips which will be used by different providers. And if one company says they are able to produce these, they are able to train their models with so low cost and without using, big GPUs and TPUs, then the people forecasted that, okay, now this is the AI has training AI systems, it has become affordable. Okay, so the share price was basically, there was some correction in the share. Anyway, so this is how they are trained. This is called pre-training, and this is pre-trained model. Okay, and this is unsupervised. So this is the key takeaway. After the pre-training has been done, my model actually has some knowledge how the language works. It has got some basic knowledge. Now what we will do is we will fine tune it basically. Okay, so that fine tuning is like question answering. Okay, I can create one data set which has questions and which has answers. Now this is supervised training. Okay, now my training is supervised because I am passing my question as well as my answer. I am basically fine-tuning my pre-trained system so that it knows how to do question answering. Okay, I say this is the question and this is the answer, so it will know, okay, this is how it has to answer. Some fine-tuning is happening in my pre-trained model. For the translation task, what I will do, this is my English sentence, and my instruction is like convert this English sentence into German, and I say the response is, this is how you convert in the, I say my name is Surendra, I will say ish, hi Surendra. So this is the translation. I give some such examples. Okay, NER, entity recognition, named entity recognition. I will send one paragraph. I will say in this paragraph I have these places identified, these persons identified, like that. So what I'm doing is I'm basically doing supervised training of my pre-trained model. So what, let me read it out. Second phase, where the pre-trained model is adapted to a specific task, it specializes the model for a particular application. Data is smaller, this data is relatively smaller. Okay, this is huge corpus of data. Okay, so if it is like 100 petabytes of data, maybe this is just 1 gigabyte of data or so. This is very less basically. This is fine tuning. You are actually tuning your system. It has built some understanding. Now we are just tuning it to perform a particular task. We are fine tuning it. Task supervised learning with the label data enhance model performance on a specific task, reduces needs for large data sets, can overfit if not properly managed, requires high quality of label data. Okay. So what happens when you pre-train the data? Maybe it is able to do all these tasks in some capability. Okay. So it can do some question answering, some translation, and some NER also, but maybe it will score 5 out of 10. Okay, after pre-training. So what I will do, I will train it, let's say, on question answering. Then once the fine-tuning is done, it may score maybe 9 out of 10. It has now become perfect in question answering, but it may get worst in translation and NER. And after fine-tuning, maybe it will perform like 4 out of 10 in translation and NER. Okay, so this is on it. So there are two parts of training. First training is being unsupervised. Second is supervised based on my task specific needs. LLM providers. So what are the different companies who are actually creating these large language models? Okay, so there are basically, proprietary LLMs, for example, these are also called as the closed source. They are not openly available. You have to pay for them to use. For example, OpenAI, we have GPT 3.5, GPT-4, GPT-4o. Can anyone tell me other models from OpenAI after GPT-4o? Is there any model which has been released? Everybody is sleeping? So
we don't know the I don't know the answer.
So there is like GPT O1 also, and I think O3 mini is also being released last week. O3 mini. Okay, so these are the models, and O1 and O3 are called as the reasoning models basically. Okay, so we have OpenAI models which are closed source or the proprietary models. We have from Google like Gemini 1.5, Gemini 1.5 Pro, and there is another company which is called Anthropic. So there were a couple of people who used to work for OpenAI. They exit OpenAI and they had their own startup which is called as the Anthropic. Okay, so they had this startup Anthropic and they have very good models as long as the coding is being concerned, right? They have like Claude, Haiku, Sonnet, Opus. So these are a couple of models from the company Anthropic. Now we have DeepSeek and we have Qwen as well. Some Chinese models are, coming into the market. There is a model called Qwen, Qwen, Qwen 2.5, which is also very good in coding, and DeepSeek, which you have heard. So these are basically closed source models. I think DeepSeek is an open source, so it should come in this category, not this.
So Suren, why you had not mentioned Grok in open source LLM? You have mentioned other providers, Hugging
I will
Face
tell
and
you.
Grok.
I will tell you. Okay, so these are proprietary large language models. Second category is open source, the models which are openly available. For example, Mistral AI company is having the models called Mixtral. Meta is having Llama 2 and Llama 3. So for example, these models I can download. I can download the weights and all, and I can run them on my environment. Okay, so this is from Meta. From Facebook, we have like Llama 2, Llama 3. Right now, I think Llama 3.3 is there. They are also about to release Llama 4. Okay, so they are also very good models in companies. If you don't want to spend your money in OpenAI models, so I will tell you the industry standard. What I have seen so far, most of the time we are using OpenAI models for the client projects. If you are building some internal capability, then our second choice is using Llama models. Okay, so yes, so it can vary from person to person and company to company, but this is what I have seen. There is a third category which is like other providers. So for example, Hugging Face. So Hugging Face does not train the models on their own. Okay, so there is nothing like Hugging Face model, but Hugging Face is a platform where these models are actually hosted. This is a library, okay, or they have something called the model hub, where more than, I think, 50,000 or 80,000 models are there. You can go there and you can download those models. So this is a platform which host couple of models. They also provide some endpoints. Endpoints means they have hosted the model on the Hugging Face hardware on their platform, and you can inference those models using their APIs. So they have something called the Transformers API. Okay, don't confuse this transformer with our architecture. They have transformers as an API which you can use to invoke these models. The next is the Grok. Grok is also a platform. It's not a company who trains the model, but they have their platform, they host the model. Just like Hugging Face, Grok also hosts the models. If you have Llama models, they will host it. Okay, the DeepSeek model, they will host it. All the open source models are hosted on Grok because Grok has the very good hardwares and platforms. So, and they say that their engine is the fastest. Okay, within microseconds, you will get your response. So Hugging Face and Grok are not the model generators, but they are basically host these models. I hope this answered your question, right? Someone was asking.
Yeah, yes, Suren.
Okay. So there is one leaderboard. This is your homework. You can go to this website and you can basically see, you can actually go there and you can compare various models. Okay. What and how do you compare the models? Anyone, please? How you can say that OpenAI GPT-4 is better than Gemini 1.5, or whenever they are released, how the company says that this is better in this task and not in other tasks or something like that?
What I have seen last time when this DeepSeek is compared with the OpenAI and also there are some parameters and there are some organization to assist
Exactly.
that things
Exactly.
like a cost and my buffer memory and all these things.
Other than that, they have there is something called the benchmarks. There are some data sets which are available on which they run their model. Okay, let's say I have 1,000 questions on maths, 10th grade maths. So I will evaluate that data set on this particular model which is being released, and I will see how many of those questions that model was able to correct. So you score these models based on the different data sets which are there, different benchmarks are there. And then they will evaluate, okay, this model is good at coding because it was able to solve the coding problem. Some standards are there. Okay, some standard problems are there. So those models are asked to solve those problems, and then they actually score, okay, on this data set, they score this much, on other, they have done this much, and like that, on reasoning problems or PhD level maths and all those stuffs. And there are startups actually who are creating these kind of data also. Okay.
So Suren, this Olama is like an open source LLM, but nowadays I have seen this DeepSeek is installed with the help of Olama in our PCs.
Olama is also not a model, first of all. Olama is
Okay.
not a model. It's also a platform basically, which can
Okay.
help you to invoke these models. So I can download Olama, and I can, from their website, I can also download, let's say, Llama 3.2. So once I download, with the help of Olama interface, I can invoke or inference these models.
Okay, fine.
Right?
So Olama is interface.
Yeah, you can say interface. Okay. They also provide API. So you can write your code with the help of Olama APIs, and then you will be able to invoke these open source models. Okay. But the Olama is more famous in, inferencing your models on your local machines and laptop and all.
Yes,
Okay.
Surendra, how we can identify it's a open source, it's not a open source? Like we have a lot of AI, then what is the point where you can define that?
So once a model is released, they release some notes, right? For example, DeepSeek. So when the DeepSeek has been released to the world, they share their release notes, right? This is an open source model and all those things. So you can, or maybe you can go to the Hugging Face, or I mean, you have to see the release notes, right? Generally, we actually know, right? The if OpenAI is releasing some model that is closed source. Okay, so they want to make money.
For example, for open source, we can use that features. We can use our in that models. Like in the closed source, they have hiding it. Like they have implemented those things from their own purpose only. If we need, then we need to pay them, right?
Yes, yes. If you are using those models, that costing may be based on API usage, the number of tokens you are sending to the model and the output tokens it is producing. That cost is defined on its website. How much it will cost for the input tokens and how much for the output tokens. The cost is also different for input tokens and output tokens. So if you go to OpenAI website, it will tell you for different models what is the cost. Okay.
Yeah.
So yeah, I will move to the prompt engineering because we have just 10 minutes. Okay. What is prompt engineering? As we said, our LLMs are what? Input, text input and text output. Okay, just that machine which can take text as an input and it will produce some output. Prompt and completion. So see, this word is also like completion because it basically complete your sentence or predict the next token. Okay, so what is prompt engineering? What happens is whenever you are giving instructions or your problem to the large language model, generally those instructions have a huge impact on your completion. Okay, so the way we actually give the instruction to the LLM for a problem, that matters a lot. Crafting prompts to guide the behavior and responses of LLMs. So based on your prompt only, your completion will be generated. So it is very important to give the right prompt. Okay, and there are actually jobs for the prompt engineers also. Okay, what is the goal? Elicit accurate and contextually appropriate output. Okay, so there is something called the zero shot learning where we only and only ask our question without giving any example. For example, I say translate the following English sentence to French, good morning. Okay, the output will be bonjour. So I don't give any example in my input instruction in my prompt. Whereas there is something called as the few shot learning. That means in order to enhance the quality of my output, what I can do is I can give some examples. Okay, for example, if I want my LLM to review some movie comments, the movie reviews, to judge whether it's a sentiment analysis, whether it's a neutral or positive or negative, what I can do is I can say, review the following comment. And number one, I can give some review from a user, and then I will say this sentiment is positive. Second, I will give again another review, and I will say this is the neutral. Okay, and then I can give another example. So giving these examples in your prompt is called few shots. If the example is one, we say one shot. If the example is two, it is called two shot learning. These examples basically help the large language model to decide and to articulate how it has to respond to your question. And in the end, I will ask, tell me, give the sentiment for the following review. Okay, so that's why this is a very good practice. If you want your output to be structured, to be in a some specific way, what you can do is you can give some few short examples in your prompt itself. Okay, and then your LLM will be able to do the completion in a better way. Otherwise, what it can do is if you want your sentiment to be like 0, 1 or 2, then it will not understand that, that you want your reviews to be, your 0 means negative review, 1 means neutral, or 2 means positive. You have to give some examples. Okay, then it will be able to understand. It will be able to give you correct answer as per expectations. There is a paper. Okay, you can go to this research paper which talks about the significance of these few short learnings. Okay, so that's one thing. There is something called as the LLM versus applications. I know most of you know the difference between what is a large language model and what are applications, but still I have seen people who are confused whether ChatGPT is an application or it's a model. They say ChatGPT is a model. So ChatGPT is not a model. ChatGPT is actually an application. And behind this application, there is a model which is being inferenced. Okay, so there is a difference between application and a model. Model is what we have been talking about, right? training a model, using a model, GPT 3.5, Anthropic, Opus, Haiku, Llama, all these are models.
Sorry. Basically, model you can say it's a backend. Like for
Yes,
query.
yes, exactly. This is a backend. Okay, this is, you can treat it as one of the service in your application. ChatGPT, when you open ChatGPT, you can see it basically make a history of your previous, I mean conversations as well, right? In the left hand side. But large language model cannot do anything like that. It does not know anything about your previous conversations. Okay, so powered by OpenAI GPT-4, only input and output. Model is just like input-output machine. That's it. Application, the ChatGPT application make the capabilities of the LLM accessible and useful to the users, but it is much more than a simple input-output machine. For example, in case of OpenAI, we have the models like GPT-4, 3.5, and 4.0, and all we can access, make use of these models by using their APIs. Whereas what is ChatGPT? ChatGPT is an application which is calling either 3.5 or 4.0 or any other model. Okay. Similarly, in case of Anthropic, when we are using the Claude chat, we are actually inferencing some model in the backend, but the front end is basically a web application. Okay, so this is not a model. ChatGPT is not a model. It's a web application which help you to interact with your LLM in the backend. So this is again some text on it. What is LLM and what is this? So this is a user. It will use the ChatGPT web application, which is having some conversation memory. It is using some storage devices to store your past conversations. Okay, so when you log in, you can see your last few days conversation in the left hand side. You can click then and you can continue your conversation, but that is being done with the help of this ChatGPT web application. You have some authentication service also, right? You have to log in. So all these are the features of your ChatGPT application, and you pass your prompt, it is passed to your large language model at the back end. So we pass the messages and the prompts and it revert with the completion. So this is basically LLM and this is your application. And in this course, we are more interested in how to build such applications. Okay, we will be interested in this part, how to create this application which can have some conversation memory. We can create some system prompts so that we can accomplish some task. We will talking mainly about this. They are already provided by various LLM providers. Okay.
So we can say our develop of our LLM, it's our output is a application.
Yes. Okay, so this is an interface for the user, and in the backend, this is one of the service, just like we have database service, we have authentication service. This is also a service where we pass some text and we get some text. That's it. How to show it to the user? What are the different options for the users? How to log in? How to log out? That your web application which you build basically. Okay, I think that is clear now. So there is another model which is called Flantify. Flantify is an earlier model from Google. Google in 2020 or 2021 released this model which is called as the Flantify model. Okay, so what is the Flantify? Text-to-text transfer transformer. Again, this is based on transformers architecture. And the beauty of this model was that it was instruction fine-tuned, meaning it was trained in such a way that it could understand the instruction of the user. All the models which you see today are basically instruction fine-tuned in the way that they can do multiple tasks based on your instruction. So in the ChatGPT, when you say translate the below sentence into German, it will read that instruction and then it will act. If you say classify the sentiment, do sentiment analysis, then it will do that. You say do the named entity recognition for the next paragraph, or you say summarize this into 3 lines. So ChatGPT or the GPT models understand these instructions and then they behave accordingly. Different tasks can be done based on understanding these instructions. So this was one of those models which was released, which was able to understand the instructions and give the output. Okay, so that's why we are more interested in the Flantify, because it is one of the earlier models and it will help us to understand how the things were there a couple of years back. So FLAN-T5 is text to text. This T5 is 5 T's, text to text transfer transformer. It take the problem as a text to text problem. A transformer based model developed by Google. Unified approach treats all NLP tasks as a text to text problem. Okay? Instruction fine tuning, open source and available in various sizes. So I will just show you in a moment how we can use this one. Ease of integration. This is on the Hugging Face and we can use it for deployments and customization. Okay, so there is again some research paper on this FLAN-T5 which you can explore. Okay. Hugging Face, what is Hugging Face? Hugging Face is a platform which a leading platform and a community, okay, where you can see a lot of AI models which are being there. You can, it's a kind of library, okay, where you can go and you can explore the different models as per your requirements. You have embedding models, you have text to text models, you have a lot of things out there. And how we can make use of Hugging Faces, I will show you in the next slide, or we will do one exercise where we will be invoking one model which is there on the Hugging Face. Okay, so it has a transformer library, which, see, if you want to use any model, you have to give it some input and you will receive some output. But there should be some library, right, with the help of which we can pass our input parameters or our input prompt, which will go to the model and it will communicate. It will translate my input text into tokens, and then it will create some mathematical representation and then send it to the model. The model will send the output. It will again convert to the natural language and like that, right? So we need some library, some interface between the user and the model that is being provided by Hugging Face in the form of Transformers library. It's an API which we can use to consume these models. Okay. What is a model hub? Model hub is, as I said, there are a lot of pre-trained models for various tasks and language, which you can find on the Hugging Face. It's like a library. Tokenizers also are available there. The tokenizers are the machine learning models, which will take your text and it will create tokens out of it. Okay, so that those tokens or mathematical representations can be understood by your LLM, your model. Next is, what is the time? We will do one exercise. This is called Google Colab. We will do it on Google Colab notebook. Okay. And what we will do is we will go to the Hugging Face. We will create our account on the Hugging Face, and then we will select our T5 model and we will write some code in the Google Colab notebook to use that model. So this is your first hands-on where you will see how you can use a model to give your own instructions and you will get the output. Are we okay to continue this session maybe for 15-20 minutes, guys? Or you are done?
We can continue.
Okay. Then let's take 2 minutes break maybe. And then we will continue for the next 20-25 minutes. Okay?
Yeah,
Yes, sure.
Yeah. So yeah, take a 2-3 minutes break, guys. We will be back. Yes, guys. Two. Give me a second.
I'm back.
Yeah. Let me share my screen. I hope my screen is visible.
Yeah, it's loading.
Yeah, now it's visible.
Okay. So what I will do is I will go to Hugging Face first. Okay. So you can see this website, right? So my screen is visible, guys. Can you see the Hugging Face website?
Yeah,
Yes.
we can. Yeah.
Okay, great. So this Hugging Face, as I said, this is a platform which is being used. It has a lot of models. It has a lot of data sets. If you want to train your model, you can download the data sets, and it has a lot other things also. So if you click on these models, you will see a lot of models out there. There are like 13 lakh 66,000 models which are present on the Hugging Face. Okay, and they are actually growing. You can see the DeepSeek also, right? But you will not see OpenAI models because they are closed source. You can see DeepSeek R1, which was released last week. You can see Mistrals. You can see if I search like Llama, you will see the Llama models also there. Okay. And in the left hand side, what you can actually do is you can, if you want to search, you can actually make the choices. If you are looking for some computer vision, okay, then you can select text to image, image to text. If you are looking for multimodal models, you can select the criteria. And then if you are trying to see some NLP, if you want to do some NLP task, based on the task itself, you can filter your models, basically audio, tabular, reinforcement. So you can go through this website, you can spend some time. Okay, so what I will do is, if you go into the data sets, you can find out a lot of data sets. Okay, what I will do is I will go on this Hugging Face and I will search FLAN T5. Okay, when I say FLAN T5, it will show me the different variants of FLAN T5. We have FLAN T5 large, T5 small, base. Okay, I can choose any one of these. Maybe I will use the base one. Okay, so you can see it's a Google model, and but it's a open source model, FLAN T5 base model, which we have selected. It has some documentation. It says model card. So there is always a model card. When someone release some model, they also release the model card, which has details about that model. Okay, so this is instruction fine-tuned, chain of thoughts, and it shows basically, let's say the question is like the cafeteria had 23 apples. It gives you some brief about that particular model. If you further go down, there are a couple of details, and okay, so inference providers, text-to-text generation, what the data sets were being used to train this model, all those details are there. So you can explore this one. Okay, use this model. This is the transformers library. So what I will do is have you opened, guys, this particular website? So once you have to log into this website, maybe you can follow after this class. I will share the recording. Let me show you very quickly what I'm trying to say. If I go to my profile and if I go to settings, I will see something called as access tokens. Okay, this is asking for my password. Okay, so these are the tokens. I will create new token and I can say demo 2 maybe, and then what kind of permission I need. I will quickly do some repository, some inference, and then I will quickly create a token. So what it will do is it will generate one token. Okay, with the help of this token, what I can do, I can log in and I can use the models which are there on the Hugging Face. So I can keep it like that. There is something called as a Google Colab, guys. Anyone of you has used Google Colab?
Yes, we started. I
Okay.
started.
Okay. So what I will do is instead of writing each and every command, I will use the Google Colab file. So this Google Colab is an environment which is there on the Google machines. Okay, so they have like Google, you can say that you are using the Google environment to run your instructions. Okay, so this file is IPYNB. This is called as the interactive Python notebook. So with this notebook, what you can do is you can actually do the documentation as well. Earlier, if you remember, if you were developing some Java applications or some other language applications, what we used to do is we create the documentation other than our code. So code was written in Eclipse or in those files. But in this Google Colab or this interactive Python notebook, what we do is we also can do the documentation very nicely. Okay, so this is about Flantify, and the beauty of notebook is that you can run cell by cell. Okay, so you in Java, what we need to do, we need to compile the entire piece of code. We need to create the dot class files, and then we can see the results. But in this particular case, what we can do is we can run our code line by line. So it is very easy to interpret basically, right? For experimentation, what you can do is instead of running the whole file, you can just go to a cell and you can just click. So what this is doing, we are installing the transformers library. Okay, because as I said, transformers is a library which will help you to interact with your models which are there, which are hosted on Hugging Face. So in order to work with those models, in order to communicate, in order to send my input instructions, I have to install the library which will help me to do so. I hope this is clear. So the command is pip install transformer. It will download the transformers library from internet and it will install it. Where it is getting installed, it is getting installed on my Google environment. Google basically has some Linux and Ubuntu machines. And right now, by accessing google.research.google.com.drive, I am creating my, installing my library on my environment on that particular machine. This is not being done locally. Okay, so I have installed my transformers library. That was my first step. Second is loading the model and tokenizer. So what I need to do, if I click on this one, it will ask. Yeah.
If we have installed one time, then it will be available for next project, or if we are doing.
Yes. So there are two
And
ways. One way is you can download your model and you can use it. Then even if you're offline, even if you turn off your internet, you can make use of those models which are there on your system. Okay, right
and
now,
how
when we are downloading this model, it is getting stored in the memory. Basically, it will go away once we terminate this session because this is a Google session, right? On internet, we are connecting to a Google machine. Yeah, please go ahead.
so it will consume the only the space, not in our email space and Google Drive space, like
Correct,
this.
correct. Yes. It will use the Google space. Okay. So when I run this command, I will share this file so that you can run it later. So what I'm doing is I'm trying to log in into the Hugging Face hub. Okay, hub is where you have your tokenizers and models. So when I run this, it prompt me for a token. This token I have already generated. I will give it paste here and I will click on enter or on login. It has got connected. Now my next step is to import my libraries. What I will do, T5 tokenizer and the conditional generator. What is tokenizer? Anyone, guys? I have explained you a couple of times today.
So generate the token like this one?
Exactly. Whenever we will give some input, my model will not be able to understand the natural language. Okay, so what I have to do is I have to use some tokenizer which can convert the words into tokens and into some mathematical format which can be passed to the model. Okay, so here what I need to do is I can give any model of the FLAN T5. Here I have given large. So if you go on the Hugging Face, if I say FLAN T5, so I will use base one. So I have selected base and there is a copy link here, right? Google FLAN T5 piece. I will click on this square. This helps me to copy the name of my model and I will put it here. Okay. This is my tokenizer. My model name is also same. I will give the name as Google/FLAN T5 base. So I am initializing my tokenizer and my model. If I run this command, it will download the model into my memory. It is done. Now I have my tokenizer, I have my model. What is my first task? To give this is input text is a variable. I am passing it one instruction. It's an instruction fine tune. So I am saying my instruction is translate the sentence into German. My name is Surendra. Okay. Why there is a question mark? My name is Surendra. Translation, translate the sentence into German language. This is my instruction. What I have to do is I have to use tokenizer to convert this into some mathematical format. So I will give this, I will use the tokenizer, which I instantiated here, and I will pass my input text. Okay. Return tensor is PyTorch. So whatever the result which will be returned, it will be in terms of PyTorch. So there are two libraries. One is the PyTorch, other is the TensorFlow. Okay. So these transformers are compatible with both of those. So I can give PT, which means PyTorch. Okay. Don't worry about if you're not able to understand what is PyTorch and what is TensorFlow. They are basically some conventions or libraries in which the output will be produced. Okay. So return tensor in the format of PyTorch, and this is my input IDs. If I run this one, okay, it has tokenized my input text. These are the tokens. If I want to see my tokens, I can do. Okay, so it has converted into this mathematical format. Sounds good. So I'm explaining this particular model only because it will help you to understand that there is a layer in between my input instructions and my language. If you are using ChatGPT, are you tokenizing your content? No, right? That everything is being done in the backend and you don't know. There are a lot of things which are going under the hood. In order to explain that, in order to reveal what is actually happening, I am showing you this old model, which is FLAN T5, for to solidify your understanding. So what it has done, whatever input text was there, it has converted that text into this words. Okay.
So Surinder, whenever the translate word that model will here, then it will give the token that 30355 always, or maybe different token number.
This one, this will be different, right? This is my word translate. What it will do, it will see into its dictionary. What is the dictionary? It has all the possible words, and they have some numbers for those words. If I change this word, this will be different, right?
Okay. Okay.
So this is my input has been tokenized. Now, in order to generate output, I will use model.generate, and I am giving those input IDs, and my output is now saved into. So if I want to look into my output, so again, this is in the form of some tensors, some mathematical format. In order to understand, I have to decode it, right? So what I will do, tokenizer dot decode output special token true. So it will say ish ab me Surendra Namen. Okay, मुझे सुरेंद्र नाम से जाना जाता है. This is the German translation. So these models are not very good at doing the task, but in order to explain you what is going behind the scene, I have explained you this one. Okay, so this can do the translation. So you can play around with this one. As far as the summary is concerned, what we have done in this notebook, this is interactive Python notebook, and we are running it on the Google Colab environment. If you have a Google account, you can hit this URL. You will see, you can then import this file, which I will share with you. Once you import, it will open this interface where you can run each cell one by one by clicking this arrow. Okay. And we can also do documentation. That's why it is called interactive Python notebook. Okay. So what is the summary? We installed the transformers library. We loaded a pre-trained T5 model and its tokenizer. We prepared our input text for translation, and we generated the output using this model, and we decoded the output into our normal text. Okay, the T5 model's flexibility in handling various NLP tasks as a text-to-text problem make it powerful tool for a wide range of the applications and so on and so forth. Is that clear, guys? So what we have done, we have used one model which is there on the Hugging Face, and we are able to inference our large language model. Was it exciting?
Yes.
Yeah.
Okay, great. So other than that, I had plans to share with you guys to run those machine learning models. So you want me to carry on, or you are tired?
No.
No?
No, Surendra, no.
Okay.
It's overburden otherwise.
Yeah, right. I think I don't want to.
So, Surinder, if you are agree, I have one question. For a DeepSeek can be.
Yeah, tell me.
Actually, what I have seen for DeepSeek is different from other like OpenAI models, and there is a one thing is reinforcement learning. So this reinforcement learning is making a differ DeepSeek from other LLM environment or something else also there.
I'm not very much sure on that.
Okay, no problem.
I mean, I have not gone through into much details of DeepSeek. I mean, what I have heard is they have stolen some data of OpenAI and things like that. OpenAI bhi doodh ka dhula nahi
Actually, it was a fake news. Actually, you know very well this US guys and all are only they want to become a number one. If other one doing something there, then they are imposing.
So Microsoft has partnership with the OpenAI. So at one side they are saying they have stolen the data and they have done so and so. We have proofs. And the next day they have hosted DeepSeek model in the Azure. So now you can use DeepSeek in the Azure. So all those things are part of the game. So yeah, I think you were able to grasp something today. Okay, I have completed one lecture in 2 sessions, but hopefully this is helpful for you guys to create some foundation, some base on what we are actually doing. what is LLM, how they are trained, how to inference, and all those things.
Today class very much appreciation compared to last class maybe some difficulty, some environment wise it's very critical, but today I'm feeling it.
Yeah. I mean, last Saturday I was actually very tired, after doing Monday to Friday office. Giving lecture on the Saturday morning it's a bit challenging, right? Anyways, I think this is all for today, and hope you guys have enjoyed. If you have any questions on this, you can feel free to ask those questions on the WhatsApp group, and feel free. And everyone can answer, right? We have a community, so we have to think it in that manner that we are a group of people who have the common goal to learn this Gen AI. So feel free to ask your questions, feel free to answer them also. Okay, so we are here to learn the new technology. And yeah, that is it for today, guys. Have a nice rest of the weekend. See you next week, guys.
Okay, thank you, Surendra. Surendra, I will share the mail ID so you can just share the recording.
Sure. Yeah, I will do that. Thanks. Bye-bye.
Thank you all. Bye.
Bye.